Hello and welcome you all. This is Professor Barapte, a book author of 25 plus engineering books. Dear students, without wasting the time, let us start today's topic. Today's topic is capacitance or capacitors, and we'll be studying series and parallel connections of different capacitors. This is the topic related to the subject basic electrical engineering for first year students. First, we'll discuss the definition of capacitor. Capacitor is an element or device that has ability to store charge. So capacitor can store the charge. Now, in a simplified way, the capacitor is shown like this. There are two plates. This is one type of symbol, or capacitor can be shown like this. Now, this is the symbol of parallel plate capacitor. Between the two plates, the dielectric material is existing. This dielectric material acts as an insulator. So, ideally, any charge will not flow through this insulator. Now, there are different connections of the capacitor. What we will be studying in this video, I'll be teaching you the basic concept of capacitor, and we'll be solving few numericals related to the series and parallel connections. I have collected the numerical in such a way that all the varieties are well covered. So watch this video till the end. First type is the series connection. I have shown three capacitors, C1, C2, C3. C is the notation which is used to represent a capacitor. The value of capacitor is known as capacitance. So three capacitors are there, C1, C2, C3. They are connected one after other in the same wire. This is called a series connection. In case of series connection, what do you need to remember? Always keep in mind, for series connection, the charge Q remains same. Charge Q is same. The basic equation of capacitance is C is equals to Q upon V. C is the value of capacitor, Q is the charge, and V is the voltage across capacitor. So for series connection, charge Q remains same, whereas there are different voltages. Voltage across C1 is V1, across C2 is V2, and across C3 is V3. So for series connection, what do you need to memorize? Charge remains same, but the voltage is different. On the contrary, look at this diagram. This is the diagram for parallel connections. I have considered three capacitors, C1, C2, C3, which are connected in three different lines, three different wires. This is known as parallel connection. In this case, all the capacitors are connected in the same wire. There are different wires, so this is known as parallel connection. Voltage V is applied to this structure. Now, in case of parallel connection, charge Q is different. It is opposite to that of series connection. So, for parallel, charge Q is different, whereas voltage is same. Very simple. It is just opposite concept to that of the series connections. Now, I have written the formulae for a quick glance. Capacitance is Q by V. For series connection, equivalent capacitance is denoted by CS. Suffix S stands for, it is the series connection. Formula to calculate the series total capacitance value of a series connection is 1 by CS is equals to 1 by C1 plus 1 by C2 plus 1 by C3 and so on. There can be n number of capacitors. Whereas for parallel connection, the equivalent value of capacitance is denoted by Cp, and it is simply given as C1, C1 plus C2 plus C3 and so on. How do you memorize this formula? Very simple. It is exactly opposite to the series and parallel connection of resistors. So these are the formulae we need to apply while solving the numericals. So let us solve few numericals to get an idea of this concept. The first problem is three capacitors, 2 microfarad, 4 microfarad and 6 microfarad. While reading the question itself, be habituated of writing the things, given things in terms of notation. So C1 is 2 microfarad, C2 is 4 microfarad and C3 is 6 microfarad. Are connected in series across 200 volts DC supply. So given voltage is equals to 200 volts. Find equivalent capacitance and voltage across each capacitor. Now, since the capacitors are connected in series, just now I explained you the concept. In case of series connection, voltage is different, charge remains same. First, let us calculate the equivalent capacitance. We have the formula to calculate equivalent capacitance. So I will first write the formula. 1 by Cs is equals to 1 by C1 plus 1 by C2 plus 1 by C3. Cs is the value of equivalent capacitance. So this is simply 1 upon 2 plus 1 upon 4 plus 1 upon 6. Do remember, all the units are same, microfarad. So I am not making any conversion. Still, if you want to convert it, do remember this. 1 microfarad is equals to 10 raised to minus 6 farad. Farad is the basic unit to measure the capacitor. It is a SI unit. So I haven't made any conversion. If you solve this, you will be getting answer of 1 by Cs. Do remember, this value, after performing this calculation, you will get answer of 1 by Cs. You want Cs, so take the reciprocal of that answer. So value of Cs, that is equivalent capacitance, will be 1.091 microfarad. This is the answer of first part. I will say this is first step. I have done the calculation of Cs, that is equivalent capacitance of series connection. Second step, what else is asked? Voltage across each element. Now, before that, we will calculate the charge, value of charge. As we discussed, in case of series connection, charge remains same. We just have to remember this basic formula. C is equals to Q upon V. Therefore, I can write Q is equals to C into V. Simply from this equation, this V is transferred at the LHS. So Q is equals to C into V. Since charge is same, I will consider the equivalent value of capacitance. So this, in this case, the formula is written as Q, that is charge, is equals to Cs into V. Simply put the values. Value of Cs just now we have calculated 1.091. Now, here don't make the mistake. This unit is microfarad, whereas given voltage V, its unit is volt. It is SI unit. So I need to convert this microfarad into farads because voltage is given, not given in microvolts. It is given in volts. So all the units must be same. So this value of Cs 1.091 into 10 raised to minus 6. Just to make the conversion into farads into the value of voltage, that is 200. If you solve this, you will get the answer of Q, that is charge on each capacitor. Since it is a series connection, charge on each capacitor remains same. So value of charge will be 218.2 into 10 raised to minus 6. I have kept 10 raised to minus 6 as it is. Unit of charge is coulombs. If you want to write in further simplified format, you can well write it as 218.2 microcoulomb. Anything will do. This is the second step. What I did in second step, I have calculated the value of charge which is contained by each capacitor. Now third step. In the third step, what I am supposed to do, it is asked to calculate voltage across each capacitor. Again, make use of the same basic formula. So I will be making use of the same basic formula. From this, I can write V is equals to Q upon C. Very simple. V and C are interchanged. This is the equation to calculate the voltage across each capacitor. This is a series case, so voltage is different for each capacitor. So I will be writing it like this. V1, that is voltage across capacitor C1, is Q. Q remains same, so I am not writing Q1, Q2, Q3 upon C1. So you just have to put the value of Q and value of C1. C1 is 2 microfarad. While putting it, you need to write it as 2 into 10 raised to minus 6. So 10 raised to minus 6, 10 raised to minus 6 gets cancelled. It is like this, into 10 raised to minus 6 upon 2 into 10 raised to minus 6. These terms gets cancelled. So this answer will be 109.1 volts. Unit is volts. Same way we can calculate V2 using the formula Q upon C2. Again put the value of Q and C2. C2 is 4 microfarad, that is 4 into 10 raised to minus 6. Q remains same. So answer of V2 will be 54.55 volts. Likewise, we can calculate V3, that is voltage across capacitor C3. It is Q upon C3. Again the same logic, put the value of Q and put the value of C3. 6 microfarad, that is 6 into 10 raised to minus 6. So answer of V3 will be 36.36 volt. This is one type of numerical. We solved it for the series connection. Let us solve few more numericals. Next problem, this is somewhat different numerical. Two capacitors are connected in parallel having equivalent capacitance of 10 microfarad. We have written the formula. The equivalent capacitance for parallel connection is denoted by Cp. Its value is 10 microfarad. While the same capacitors when connected in series have equivalent capacitance of 2 microfarad. For series connection, notation is Cs. Don't get confused. For doing calculation, we are using the formula 1 by Cs. But value of equivalent capacitance for series connection is Cs. So given value of Cs is this value 2 microfarad. It is asked to find the values of two capacitors. That means we need to calculate the values of two capacitors C1 and C2. Now, first step is we will use this formula for parallel capacitors Cp, C1 plus C2 plus C3 and so on. There are two capacitors. So I will write it like this: Cp is equals to C1 plus C2. Therefore, C1 plus C2 is equals to given value of Cp, that is 10 microfarad. I am not making any conversion, keeping microfarad as it is. Let us say this is equation number 1. We want to calculate values of C1 and C2, but this is one equation and there are two unknowns. So I need to generate one more equation. How to do it? Series connection value is also given. So I will be writing this formula for two capacitors. It is written like this: 1 by Cs is equals to 1 by C1 plus 1 by C2. So this can be simplified as 1 by Cs is equals to, if I will take the LCM, then it becomes C2 plus C1. I am taking LCM, C2 plus C1 upon C1 into C2. We don't want 1 by Cs. We have the value of Cs. So take the reciprocal of this equation to make the thing simple. So if I will take reciprocal of entire equation, this can be written as Cs is equals to C1 into C2 upon C2 plus C1 or C1 plus C2. Simply I have taken reciprocal of entire equation. Now we have the value of Cs as well as we have the value of C2 plus C1. Therefore, value of Cs is 2 microfarad. I am writing it as 2 is equals to C1 into C2. I am keeping it as it is. We have the value of C2 plus C1, that is C1 plus C2, which is 10. Therefore, I will write C1 into C2 is equals to 20. From this, I can calculate the value of C2, or I can write the value of C2 like this: C2 is equals to 20 upon C1. Very simple. What I am trying to do, I have this equation number 1, where there are two unknowns. I am trying to convert one unknown in terms of another. So I have generated equation of C2 in terms of C1. Now say this is equation number 2. Next step is put this value of C2 in equation 1. So if I will put this value of C2 in equation 1, then equation becomes C1 plus 20 upon C1 is equals to 10 microfarad. Now we will take the LCM of this. So we can write this as C1 square plus, I am taking LCM of LHS side, C1 square plus 20 upon C1 is equals to 10. This will give me C1 square plus 20 is equals to 10 C1. Therefore, C1 square minus 10 C1 plus 20 is equals to 0. What I did, I have transferred this term at the LHS. To get the quadratic equation, I have shifted all the terms at the LHS and I have got 0 at the RHS. Let us say this is equation 3. Now, simple step is you just have to calculate the roots of these equations. If you calculate the roots of these equations on the calculator, you have to do these calculations on the calculator. If you don't know how to calculate the roots on the calculator, do watch the video which I have created for the calculations on scientific calculator. I will provide the link. Alright. So if you calculate the roots of this equation on the calculator, answers of these values C1 will be 2.76 or 7.24 microfarad. I haven't made any conversion, so unit remains microfarad. These are the answers you will get on the calculator. Since it is a equation which is having power 2, you are getting 2 answers. Any one value we can select. This is the value of C1. Now, how to calculate C2? We have equation 2. So, make use of equation 2. So, from equation 2, we have C2 is equals to 20 upon C1. So first put C1 is equals to 2.76. Do the calculation, you will get one answer. Then put C1 is equals to 7.24. You will get another answer. But in the exam, you don't have to do all such things. Directly, you will be getting answers like this. C2 is equals to 7.24 microfarad or 2.76 microfarad. Just change the positions of these two values, you will get the answer of C2. So this is the calculation if both the combinations, series and parallel combinations of capacitors are given. Now one more different type of variation in such numericals. Two capacitors of 50 microfarad each are connected in parallel. To get the things more simple, I am drawing the diagram. So two capacitors of 50 microfarad are given. They are connected in parallel. And then this combination is connected in series with 80 microfarad and 40 microfarad. Make the thing simple. Series means draw it in the same wire. Parallel means draw it in different wires. So these are two capacitors in parallel. Then after that, one capacitor of 80 microfarad and another of 40 microfarad connected in series one after the other. It is asked to calculate the equivalent capacitance of the total structure. How to do it? Make the thing simple. This is the parallel combination. We have the formula to calculate the value for parallel combination. So in this case, it is Cp is equals to 50 microfarad plus 50 microfarad. Very simple. It is C1 plus C2 plus C3 and so on. That is here only two values capacitors are in parallel. So I am simply adding the two values. So answer will be 100 microfarad. This is the answer of only parallel combination. Now this 100 microfarad will be in series with this. How will you come to know? Very simple. Whenever you are taking parallel combination, delete these two. Mark only one capacitor because we have now calculated the equivalent value. It is denoted like this and this value is 100 microfarad. So if you just refer this same diagram, all the three capacitors are in same wire connected one after other. That means they are in series and we have the formula to calculate the equivalent value for the series connection. So finally, let us make use of this formula. 1 by Cs is equals to 1 by C1 plus 1 by C2 plus 1 by C3. Therefore, 1 by Cs is equals to, simply I am putting the values. There are three capacitors now. 1 by 100 plus 1 by 80 plus 1 by 40. Like the previous two numericals, I am not making any conversion. I am keeping microfarad unit as it is. Final answer will be naturally microfarad. After solving this, you will get the answer for 1 by Cs. Without fail, take the reciprocal of this answer because we now want the answer for Cs, not for 1 by Cs. So after doing this calculation, you will get some value that is equivalent to 1 by Cs. Take the reciprocal of that. So final answer is 21.05 microfarad. So these are the different types of numericals which I covered in this video. Dear students, this is the possible variation as far as series and parallel combinations of capacitors are concerned. If you like this video, don't forget to smash the like button, and if you haven't subscribed the channel, don't forget to subscribe the channel. Thank you very much.